So I just want to remind you what we did yesterday at the very end of class. Okay? So first of all, we were talking about our proof strategy, where you're going to get a statement in terms of n. You have to, number one, show it's true for 1. Then assume it's true for k. So you can show that the k plus 1 is true. And once you've done that, you can conclude that your formula is true for every positive integer n. Okay? So we show it's true for 1, we assume it's true for k, and use algebra to show the k plus 1 is true. So go to this proof that we did yesterday, wherever it is in your notes. And let's just talk through what we did before we do a second one. Okay, so we were given this formula, S of n. We plugged in 1, so we took the first term and we plugged in 1 over here to make sure that they were equal. Okay, our second step, we literally write the word assume, and then we change everything to k's. Our next step was then to look at the k plus 1 sum. The k plus 1 sum has the first k terms, but then we have to add the k plus 1 term. So whatever this was, we substituted in k plus 1 for k, and that was our next term. Okay? We don't know what this equals, but since our k sum equals k squared, then we want to show our k plus 1 sum equals k plus 1 squared. Okay? If we get there, then we've done what we need to. Okay? This will happen every time. The 1 plus 3 plus 5 plus 7 plus all the way to 2k minus 1. We know that that equals k squared, so we could rewrite it as k squared. Okay? This k plus 1 term, we just rewrote it to be 2k plus 1.
It is fixed down here.
Is it? Oh, that's good news. K squared plus 2k plus 1 factors to k plus 1 squared. So then we wrote our conclusion. Therefore, our formula is true for all integers n. Okay? Were there any questions you didn't get to ask yesterday when we went through this proof? Okay, so we are going to go through one more, and then you have 5 to do for your homework. You'll get to start that here once we're done with this proof. Okay? So my goal is that you're going to have a good 35 minutes to work on your homework. Okay? It gives you about 7 minutes per question if you want to try to get through it all. Okay? So go ahead and write down this formula here. This is the next one we are going to prove. What's the first step of our proof? Show it's true for 1. So the sum of our first term, well, what is our first term? 5 is our first term. We need to show that that equals this over here when we plug in 1. So I literally want to see that all you did is replace n with 1. So I'm going to write 1 times 1 plus 4. I want to see that. I want to see that it matches. Okay? Well, what is 1 times 1 plus 4? Okay. So 5 equals 5, show me that. Okay, I like to put a little check mark like, yes, we did it. Okay. Step number 2, what's the word we write?
Assume.
And we assume what is true.
S of K equals.
So same thing but with K's, right? S of K is what, you don't have to spout it all out to me, Alice. It's kind of a mouthful, right?
Yes.
All right, so we're going to assume S of K is 5 plus 7 plus 9 plus blah, blah, blah plus 3 plus 2K equals K times K plus 4. Okay, so if we assume that K is true, we now need to show K plus 1 is true. Okay, so let's look at the K plus 1 sum. So I'm going to write then the sum of the K plus 1 terms. Okay. Remember, like we talked about yesterday, if we're going to add up the first 5 terms, when we go to add up the first 6 terms, it's that same sum plus the 6th term. Okay, so our K plus 1 sum is, I'm going to just copy paste our K sum plus, okay, you swallow her? You're not like choking on something. Okay. All right. Here's our K sum. We need our K plus 1 term. So our next term would have the same model, but with a K plus 1 inside. Okay. Now, we do not know what this equals, but we know what we want to show that it equals. Okay, so don't write an equal sign yet for K plus 1, or really at all. Okay, if the K sum is K times K plus 4, then we want to show that our K plus 1 sum is what? If the K sum is this, okay, so K plus 1 times K plus 1 plus 4. So K plus 1, K plus 5. Okay. But we can't write it until the end. So my suggestion would be to skip a few lines and write it so that you know what you're working towards. Does that make sense? Here, I'll highlight it here in green. That's what the K sum is. So we're going to change it to K plus 1. Okay? All right, well, now how do we do that? What do we know about 5 plus 7 plus 9 plus blah, 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 plus 3 plus 2K? Okay, that's our K plus 1 sum, right? So we have, I mean, it's literally right above it. So we can replace it with K times K plus 4. Okay. And then we have this 3 plus 2K plus 1. Would you agree that that's the same thing as 2K plus 5? Okay. Here's the deal. I need somebody in Algebra 1 to be able to follow your steps. If somebody from Algebra 1 could not follow your steps, then it's not enough work. Okay? We need to get to this right here. What should we do? Let's distribute. So we have k squared plus 4k plus 2k plus 5, which we then could combine like terms to k squared plus 6k plus 5 does that factor to k plus 1 times k plus 5. All right, we did it. You know what your work needs to get to, okay? Just make sure you have legitimate steps on your way there, okay? But we know that k squared plus 6k plus 5 should factor to this. That was our goal to get there. So now we can conclude that our formula does work. Okay, so write me a sentence. Therefore, our formula, go back to your ends. Therefore, it is true. So therefore, our formula is true for any positive integer n. Okay, we probably should specify that they're positive integers. I don't know if I did that yesterday. All right. Questions? Thoughts? Okay, yesterday when I said proof, all you guys could think of were those 2 column proofs from geometry. Okay, would you agree that this is much different? It's really all algebra based, would you agree? Okay, so this is my plan. I would like you to work on your homework, but I don't want to just like make you swim with the fishes. So once you have completed number 11, call me over, I want to check it over, okay? And if you and somebody work together, then I can check yours kind of at the same time, that's fine. But what I'd like to do is I'd like to check in with you after each homework problem to make sure that you have the formatting of it correct. Okay? So same page as yesterday. I believe you have numbers 11 and 12.
14, 15, 17.
14, 15, and 17. All right.